Hi guys, good afternoon everyone. So today we will present about our mathematics project, which is about trigonometry in problem life situation. So again, before that, we also going to introduce about our Sustainable Development Goals or SDG. Our objective also is to show how trigonometry and mathematics can be used to solve problem solving in your life, especially in environmental conservation and engineering. So then our comment also is about around SDG 14 about life below water. Through our story, we demonstrate how trigonometry plays a crucial role in structural stability, in movement underwater, and problem solving in many ecosystems. Okay guys, so before we dive deep into our calculation, let's first understand why trigonometry is important. So trigonometry is important because trigonometry helps in measuring distance, angles, and force, making it essential in engineering navigation and environmental studies. So in our comic, our character use trigonometry to solve real life problems, such as like calculating stability of artificial reef, and the last one is about determining the correct angle in the movement of underwater.
Alright, so now let's go into the calculation part in our comic. For the first scene, it shows an underwater rower got stuck in a rock. So our character Joya uses trigonometry to find what is the force as well as the angle to push the rover out. So it shows here that mathematics, or specifically trigonometry, can be used to help the underwater exploration. In the first scene, it shows here that this underwater rover is at the angle in 35 degrees. So we have to find what is the speed that Joya needs to push this rover in order to get it out, which is I label it as B, and then the overall speed, which I label as C, in order to be greater than 40 meters per second, because the rocks will collapse at the speed of 40. So we assume it to be a right angle triangle. So the angle will be here, and then the C will be here, B, and then A equals to 40. So cos 35, we know it would be 40 over cos 35 degree. So the answer would be 48.83 meters per second. And then that is for C, which is the overall speed. Now for the B, which is the speed that needs to be exerted from the Joya, is sin 35 equals to B over C. So C we have known, so B equals to sin 35 times by 48.83. So we got the speed as 28.01 meters per second. Okay, for the second part, it shows that Joya and her partner are in the process of building artificial reef in a hexagonal prism. So they use trigonometry as well to calculate its volume in order to determine whether the coral reefs they are building could fit in or not. So here is the calculation. 2 square minus 2 square, and we got C as 33 meter. So now let's calculate the area, which is 1/2 times 2, which is the base, and then the surge 3. So we got is as 3 meters. So as it has 6 triangles, this means the area will be 6 times surge 3, so it would be 6 surge 3 meters square. And then finally the volume is the thing that we want to find. So we assume that the height of this prism is 5 meters. So 63 times 5, it would be 51.96 meter cube. Last but not least, for the last scene, it shows a hunter is really close to a fish. So Joya uses trigonometry as well to find what is her distance from the fish in order to know what is the velocity she should be in order to reach the fish first. So let's step into the calculation. The distance of the fish from Joya is 100 meters from vertical direction. So we assume it to be as right angle triangle as well. So the angle is 40 degree. And then here is the thing that we want to find, which is the hypotenuse. And this is the vertical distance. So in order to find A, we know that sin 40 equals to 150 over A. So A equals to 150 over sin 40. So we got as 201.31 meter. Alright. And then we assume that the speed of the hunter is 3 meters per second. So and we also assume that his distance is 100 meters. So time equals to D over V, so 100 over 3. So the time we got as 33.33 seconds. And then how much with the velocity of Joya that she needs to be in so that it could reach the fish first. So V equals to D over T. So it's her current distance is 201.31 over 33.33. So it would be as 6.04 meter per second. So this is the velocity that Joya needs to swim to the fish in order to reach the fish first.
Okay, then we have come to the end. So through this comic, we have been shown that trigonometry is not just a subject in our textbook. It's also a tool to solve real-life problems right now. By combining maths, mathematics, and SDG goals, we can develop solutions that protect economic system and improve infrastructure sustainability. Thank you again for your attention. We hope you found our presentation a bit joyful and insightful. Bye guys!